All right, welcome to our next video. This should be our first video of the loops playlist. Our objective of this video is going to be to cover the for loop, which is a tool for handling repetition. A for loop has three components. It's got an initialization, a test, and an update. We're going to talk about those. We're going to talk about what it means to be an incrementer and a decrementer. And we're going to see an example of using for loops to calculate one number to the power of another number. So we're going to look at for loops applied to exponents. All right, so the purpose of each of these videos is to address a problem or a hurdle you might have if you are trying to perform some kind of computational task and you need to solve a problem. What's the right tool to fix it? And our problem today that we're going to try to address is repetition. We've been working with the basics. We can do print statements. We can make some variables. We're starting to understand the basics of string literals. So I asked the question, what do you think you would do if you needed to print out hello world 5 times, 50 times, 1,000 times? Surely we would not want to do that. We wouldn't want to write out by hand 1,000 print statements. I think that could be an example of something that we call brute force, which you could write 1,000 print statements that prints out hello world, but it's just inefficient and frankly gross. So what we're going to do instead is we're going to use something called a for loop. Java has a couple different kinds of loops. There's the for loop and the while loop. One is considered definite in that we generally know the quantity of times it's going to run. The while loop is considered indefinite. It will usually run until a condition is met. There's often some variability in there. So we're going to talk just about the for loop for today. If you've ever messed around with Scratch or Snap before, you'd be familiar with a block called the repeat block, and it usually says repeat 5 or repeat 10, and that means whatever's inside of it, you're going to do that number of times. Well, in Java, we add a little bit more complexity to give ourselves more control. So the idea is we want to be able to decide not just the number of times we repeat, but we're going to track how we repeat with an index. An index is going to be a number that we use to track where we are in our loop. So let's do an example. If you are watching this video, I invite you to type this code into BlueJ or whatever your IDE of choice is. See what you think and see if you can mess around with it. So here we go. I'm going to say for int I equals 0. I use a semicolon to separate these three parts of the for loop. Int I equals 0, I less than 3, I plus plus, open curly, closing curly. Control K to make sure we compile. Looks great. So what I'm going to do is inside the body of this for loop, I'm going to make a print statement, system. We'll do the old classic, the old standby hello world. We go to run it, and there it is. So something about what you see right here means that you are to execute 3 times. And let me walk through what it is that you're looking at so you can understand how this works. So there are 3 parts of a for loop. The first part is called initialization. I'm just going to abbreviate that as initialization. Yeah, we'll do the whole thing. Okay, this is a statement that is executed once at the start of the loop. Its purpose generally is to create a new variable. The convention is usually it's an int, and usually that variable is called I, because I stands for index. And this is going to be how we're going to track our loop. All right, so then the second part is called the, not the update, that's the last part, the test. This is the condition which terminates the loop. So as long as our value I meets this condition, we're allowed to keep looping. If at any point I reaches a point where it's going to fail, the next time we test our loop, we will exit the loop. All right, so the last thing is called the update. In this case, I++ is our update, and is the job of the update to advance the index toward the test. So if our place that we're stopping is 3, and we're starting at 0, then I++, which is short for I equals I plus 1, or I plus equals 1 would be the other shortcut for describing it. It just says, hey, I, whatever value you were, increase your value by 1. All right, so what does this do for us? Well, we see that when we execute this loop, it's going to hold a few values for I. So when it starts out, I is 0. We test the value before we ever enter the body of the loop. And seeing that 0 is less than 3, we pass. So we're allowed to print hello world. Then we update, and I becomes 1. We test I again, 1 being less than 3, we pass. And so we print out hello world. We hit our updater, and our updater takes I to 2, and we test it. And we see that I is less than 3. So we continue, we get our third hello world that's printed out. We do update one more time. I does become 3. We ask the question, is 3 less than 3? And the answer is it's not. They're equivalent. So this finally, instead of returning true, it returns false. And we exit our code. So we would say that the pattern of the for loop is that we will go, we initialize, and then we go test, body, update, update, test, body, update. And we do this over and over until the test fails, at which time we exit. So test body update, that's how we continue to loop over and over. All right. So these for loops can be built a few different ways. This particular one, in my class, we call this an example of an incrementer. And we call it an incrementer because the updater advances positively. But I could just as easily have set up this for loop to go backwards, if you will. So I could say, hey, look, int I equals 5. As long as I is greater than 0, and then I minus minus. So up here I said start at 0 until you hit 3, advancing by 1, and that gave me 3 hello worlds. Now I can say start at 5, go until you reach 0, and decrease by 1 every time. And instead of doing hello world, let's print out APCS. And let's run our for loops main method. And here we see we still get our 3 hello worlds, and we get 5 APCSs. There is some slang that I use in my classroom for initialization, test, and update. We call these things the start, the stop, and the speed. We call it these things because the start tells you the initialization where to start. Are we starting low? Are we starting high? What are we doing? The stop tells you when your test terminates. And we call this third part speed because it turns out you don't always have to say I plus plus or I minus minus. For example, I could choose to update my I not by 1s but by 2s. So I could say I plus equals 2. And when I go to run it now, boop, we see, oops, I lost a hello world. What happened here? Well, I was 0, that passed, and I got a hello world. But instead of increasing to 1, I got increased to 2. So 2 being less than 3 still passed. I got a second hello world. But then when I was advanced one more time, it shot all the way up to 4. That failed, which means we only made it 2 times through our loop. So when we talk about start, stop, and speed, I have the option of making my loop run forward or backwards. And I can have it run more quickly or more slowly. And by distancing the start and the stop far apart, I can make the loop run more frequently. By putting those start and stop close together, I get fewer times through the loop. And by increasing the speed, I'll get fewer times through the loop. Okay, so that's an example of for loops. The last thing I'm going to add in here is how could I use a for loop to approximate raising one power to another power. Just for the record, and we're going to talk about this later, you can say math.pow of 3 comma 4 if you wanted, and this would be the same thing as saying what is the number 3 raised to the power of 4, or what is 3 times 3 times 3 times 3. A good practicing tool for for loops is let's try to use for loops to make the same thing happen. So let's say I had 2 numbers. I'm going to call the first one base, and I'll set it to 3. And I'll call the next one power, and I'll set it to 4. And what I want to do is I want to multiply these numbers together. I want to multiply 3 together 4 times. Anytime I see repetition going forward, I should start to think, there's got to be a better way than the brute force technique of just spelling it all out. Brute forcing means it's clumsy, it's hard to alter, it's time consuming, it's inefficient, it's often unreadable. We don't want that. So rather than just manually type out 3 times 3 times 3 times 3, which I can do, that's fine. Look, I did it and it's done. But what if I change my mind? What if I don't want 3 to the 4th power, I want 3 to the 8th power, or the 2nd power, what have you? So let's make a for loop that gets the job done here. I'm going to say for int I equals 0. I'm going to say I less than, all right, what's the number of times I want to multiply this number in? Well, I think I want to multiply it 4 times. So if I want my loop to run 4 times, I generally start most of my loops at int I equals 0. I'll go ahead and set my test at I less than 4. And no reason to have a fancy updater here. We'll just say I++. Then what I'm going to do is I'm going to do something called priming the loop, which is I need a variable available inside the loop. So I'm going to declare it out here. So I'm going to say int result is what I'll call this guy right now, and I'm going to set it equal to 1. Remember, what we're trying to do is we're trying to approximate this math.power of 3 to the 4th. All right, so what I'm going to do inside my loop is I'm going to say, all right, result. Whenever you run through the loop, would you multiply yourself by whatever the base is? So the first time through the loop, you're going to be 1 times 3. And whatever that is, that's now what result is. So 1 times 3 is 3. Result is 3. The next time through the loop, we'll say, hey, result, what were you? Oh, you were 3? Well, multiply yourself by 3 again. Now that's what you are. So a result becomes 9. We do it again. Result becomes 27. We do it again. Result becomes 81. Let's test to see if we got this right by printing out result. Ta-da! And there it is. This is how to use a for loop as an approximation for exponents in programming. All right, thanks for watching.